Show that f equals 2xy plus z cube times I, x squared j plus 3x squared z squared, and is a conservative force field. Conservative force field. So we are going to show that is a conservative force field. Conservative force field means curl f equal to 0. Okay. So earlier we were discussing about irrotational, and this is the condition for conservative field, which is nothing but del cross f equal to 0. So curl f, find out now curl f. So del cross f. So you have now del cross is nothing but you have ijk partial d by dx, partial d by dy, partial d by dz. You have 2xy plus z cube, x squared is here, 3x z squared. As usual, so you have partial d by dy times 3x z squared minus partial d by dz times x squared. So you have this term and you have last term. When you are going to differentiate with respect to y, will give you 0. When you are going to differentiate with respect to z, that will give you 0. Simple. There is no z term here. There is no y term here. So answer will be 0. Now here x term is there. See, x term is there. So we have 3z squared. And we have now z term is here. Correct? So we have 3z squared. And the last one we have x term is here. And here also we have y term. So 2x minus 2x, that will be 0. This also will be 0. So your curl f is 0. It implies that it is a conservative force field. So it's a conservative force field. For any conservative force field, this condition should be satisfied. That is curl f equals 0. Now, earlier, can you remember? So we find the scalar product of f. See, we have done solenoidal as well irrotational. We have not done this scalar product of f, correct? So for this problem, you have to find out the scalar product of f. So the answer is f equals del f. You have to find out del f, del phi. F is given as this. Okay. For this problem, for previous problem, this problem f is given. We have to find out the scalar product of f. So f equals del phi. We know already f equals del phi. What is f? F is this one. F is this one. Del phi is I d phi by dx plus j partial d phi by dy plus k times d phi by dz. Now you can compare. When you are going to compare ith term with ith term, left hand side and right hand side, that will give you d phi by dx, which is equal to 2x plus yz. Now j term with j term, d phi by dy will be 4y plus zx. Then k term, d phi by dz will be minus 6x minus xy, minus of 6x minus xy. Now you have d phi by dx equal to 2x plus yz. We have to find out now f. What is asked? What is asked? The scalar product of f. Okay. So you have to find out now phi. When you are going to find out phi, you have to integrate. So when you are going to integrate, so that will give you integration of d phi by dx will be phi. Integration of d phi by dx will be your phi. So your phi equals integrating. When you are going to integrate, that will become x squared by 2. So x squared by 2. When you are going to integrate with respect to x, that will give you y is at x. Plus some integration constant must be there. That constant is nothing but f1 y comma z. f1 y comma z. So you have phi equals 2 will get cancelled. X square plus xyz. This can be written as xyz plus this constant. Similarly, we have to compare this with this as I said earlier. So this with this, that will give you d phi by dy, which is equal to 4y plus zx. When you are going to find out y, you have to integrate. You have to integrate. So this is the thing earlier. This is the expression, earlier expression. When you are going to integrate with respect to y, that will give you your phi, and that side will be 4 y squared by 2, y squared by 2 plus xyz plus integration constant. Now this 4 and 2 will get cancelled. You have 2y squared plus xyz plus integration constant. Now comparing the kth component, that will give you d5 by, see kth component, you will have to compare with the kth component, this equal to this. So that will give you d5 by dy, which is equal to minus xz plus xy. So integration, that will give you minus 6z squared by 2. Integration of this will give you x, y, z, and integration constant. Your 5 will be cancelling these two, that will give minus 3z squared plus xyz plus f3 x comma y. Now you will have to go for just equation 1, 2 and 3. Combining all those things will give you your 5. So you have to compare, you have to combine. You have to combine first equation, combine second equation, combine third equation, and similar terms should be cancelled. Similar terms, you should not include similar terms. See here, you have x squared plus xyz integration constant. We have this term, we have this term. So combining these two, all the three, that will give you x squared, similar terms. See here, xyz similar, xyz similar. They are also similar. So you have to write only once. So xyz plus 2y squared, and this will be minus 3z squared. For all the constants you can write capital K or small k. So your k will be for rest of the constants. So this is the answer. Now very important problem, we will solve one problem. R to the power, show that R to the power n, R vector is an irrotational vector for any value of n, but it is solenoidal only if n equal to minus 3. See, I repeat, and this is for all values of n, this is irrotational, and for n equals 3, this is solenoidal. When you are going to substitute n equal to minus 3, and this becomes solenoidal, whereas for all values of n, this becomes irrotational. So I repeat, R to the power n, R vector, for all values of n, this is irrotational. When you are going to substitute n equal to minus 3, this will become solenoidal. So you have to show R is a position vector. We know already this. So first we will have to find out now irrotational. So del cross R to the power n, R vector, for any irrotational we know already this. So your del cross R to the power n, R vector, which is equal to, this can be written as like this. So you will have to prove that whether it is 0 or not, we will have to prove. So we have, as usual, d by dy times R to the power n z minus d by dz times R to the power ny minus j for the second term and for the k third term. Okay. So I have written the same thing. I have written the same thing here. Now you have to differentiate with respect to y here. There is no y here. So the answer will be 0. Now you have to differentiate. Keeping this as constant, you have to differentiate this. Keeping this as constant, you have to differentiate this. As we have done earlier. See, differentiation of x, y will be, keep x as constant, you have to differentiate y, so dy. Then you have to keep y as constant, you have to differentiate x, so y dx. So similarly, R to the power n is that you have to differentiate this, keeping this as constant. You have to differentiate this, keeping this as constant. So when you are going to differentiate with respect to y, there is no y here, only z is there. So answer is 0. Now when you are going to keep this as constant, we will differentiate this. So when you are going to differentiate R to the power n, give you n R to the power n minus 1 dr by dy. Is it okay? R to the power n R to the power n minus 1 dr by dy. Similarly for the next one, you will differentiate this. Keeping this as constant, you will differentiate this. Keeping this as constant, you will differentiate this. Already we know that we will differentiate with respect to z. So y is there. So answer must be 0. So straight away you can write y, let it be y here. So n R to the power n minus 1 dr by dz. For jth term the answer will be like this, and for the kth term answer is like this. Okay. Now we can pull common terms, n R to the power n minus 1. Here also n R to the power n minus 1. Here also n R to the power. So you can pull n R to the power n minus 1 common out. So that will give you dr by dy z. See here, dr by dx and z. So we have dr by dy z. See, dr by dy z. Okay. Similarly, for the next term will be dr by dz y. So dr by dz y for the ith component. Similarly, for the next one and next one. What is dr by dy z? We know already, we have earlier we have found out. However, we can simplify, and we know that r vector is given as xi plus y j plus zk. So modulus of r will be root of xi plus y squared z squared, and r squared is given by this. You can differentiate this with respect to x will give you d by dr by dx will give you x by r, dr by dy equal to y by r, dr by dz equal to z by r. So you can substitute dr by d is dr by dy y by r, you can substitute here. So when you are going to substitute, we will have y z by r minus z y by r. See, z x by r minus x z by r, y x by r minus x y by r. See, all those things are equal, so it becomes 0. So del cross r to the power n r, which is equal to 0. So answer is 0. It implies that the irrotational value, that irrotation is satisfied for all the values of n. Whatever may be the n value, it will become 0. So this is what is asked. For all the values of n, this is irrotational. See, we have proved that this is irrotational. Okay, this is irrotational. Now the second one is, we have to prove that for n equals minus 3, it is solenoidal. For n equals minus 3, it is a solenoidal. We have to prove. This is for all values of n. This is for n equals minus 3, we have to prove that it is a solenoidal. So del dot for solenoidal, del dot f equal to 0. So del dot r to the power n r vector equal to 0. First we will go for left hand side. Left hand side is given as this. So your del is here, your r is here, correct? R to the power n, instead of r vector you can write xi plus yj plus zk. Now I with I, so that will give you partial d by dx r to the power n x. Similarly for the next term, and similarly for the next term, you have to differentiate with respect to x. So you have now n r to the power n minus 1 dr by dx, keeping x as constant. Next you have to differentiate x, keeping this as constant. So r to the power n. Similarly next term. So you have to add all those things. So you can pull nr to the power n minus 1, you can pull. So you have nr to the power n minus 1 dr by dxx, dr by dyy plus dr by dz. And you have, see here, you have r to the power n here, r to the power n, that will give you 3r to the power n. dr by dx is nothing but x by r. You substitute x by r, already one x is there, so x squared by r, y squared by r, that will be z squared by r. Okay, so x squared plus y squared plus z squared divided by r will give you r squared. So r squared by r and plus 3r to the power n. These are so okay, r squared divided by r will give you 1r. R squared by r will give you 1r, correct? You can cancel 1r out. R to the power 1 you can write. So we have nr, n minus 1 plus 1. See here, 1r will cancel, r to the power 1. So here r to the power n minus 1 combined together, that can be written as r to the power n minus 1 plus 1. Minus 1 plus 1 will get cancelled. You have nr to the power n, 3r to the power n. Right hand side, what is right hand side? This is equal to 0. So right hand side equal to 0. So you pull common terms out, that will give you r to the power n equal to n plus 3, which is equal to 0. This cannot be equal to 0. This must be equal to 0. So that will give you n equal to minus 3. What is asked? So it is proved that r to the power n, r vector is an irrotational vector for all the values of n, but it is solenoidal when n equals minus 3. When n equal to minus 3 only, this becomes solenoidal. So that is only it is asked. Okay. Divergence of a vector. So a equals axi plus ayj plus azk. The divergence of a is defined as. So we know already that the expression for divergence of a is given as this and this. So this is for divergence and this is for a. I with I, that will give you this expression. So div dot a is given by This we know already. Now what is asked? The expression for A is given as this. We have to determine div A. So del dot A is given by this expression. Del dot A can be written as, we have to differentiate this with respect to x, with respect to y, with respect to z individually, and we can write this. When you are going to differentiate with respect to x, will give you, so 2x y, and this becomes xz, and this becomes yz at the point 1 2 3, at the point 1 2 3. So this becomes 2 times 1 2 minus 1 times 3, and this becomes plus 2 times 3. So simplifying will give you 13. So this is what it is asked. Okay. So f is given as this. We are going to find out del f, div f. So you have del, this is your f. Okay, as usual, you have to go with I dot I, that will give you d by dx times xz. So when you are going to differentiate with respect to x, will give you z. This will give you xz, and there is no z here, so answer is 0. Okay, so that's all. Del dot f is nothing but, we can pull z out, so z 1 plus x. So f is given by this. Pi plus qj plus rk is a vector field, and p, q, r have continuous second order partial derivatives, and show that div curl f equal to 0. So this is very important vector identity. Div curl f equals always it will be 0. So first we will go for first div del cross f, div curl f. So div is can be written as del is here dot del cross f. First we will go for del cross f first. Here del cross f is nothing but ijk d by dx, d by dy, d by z. Here p ith component, q jth component, and kth component are written. So now as usual, del cross f can be written as d by dr of by dy, dq by dz. Similarly for the second term, for the third term. What is asked? Del dot del cross f. We have found out now del cross f. Del dot del cross f. So this multiplied by this dot product with del cross f. This is your del dot with del cross f. So I dot I. So d by dx of this first term, dr by dy minus dq by dz, plus second term, plus third term. Now this can be written as d squared r by dx dy, correct? Similarly, partial d squared q by dx dz, and the next term will be d squared p divided by dy dz, and the next term will be d squared r by dy dx. Now d squared r by dx dy, d squared r by dy dx. This is plus term, this is minus term. So answer is 0. D squared q by dx dy. Here it is minus sign, here it is plus sign. So this one will get cancelled. This term and this term will get cancelled. Answer is 0. So del dot del cross f equal to 0. Very important vector identity. Div curl f will be 0 always. Now curl of a vector function. So you have vector function is given, and curl of f is nothing but this formula. Okay, determinant of ijk d by dx, d by dy, d by dz. F1 is here, f2 is here, f3 is here. Curl f is also said to be a rotation, as I said, swirling rotation. Curl means the tendency of a fluid to swirl around the point. Curl is a vector quantity. So if any vector function is given, any function is given like this, vector function is given x z I, y, x y z j minus y squared k, just find out del cross f. So del cross s is nothing but this. So simplifying will give you partial d by dy times minus y squared, and this will be partial d by dz times x y z for the second term and third term. So this will be your minus 2y, and this will be your minus xy. See, minus 2y minus xy. I have written the same thing here. You have minus 2y minus xy, and this becomes 0, and this becomes x minus x is here. That one becomes y is that, the last one becomes 0 here. So your del cross f is nothing but this expression. Okay, so what is asked? Del cross F is asked. So curl F is asked. So we have found out now del cross F. Curl of a vector. Curl del cross A is, can be written as A is given as this. So your del cross A is nothing but ijk d by dx, d by dy, d by dz, and the components of ijk can be written as like this. Now this vector function is given. We are going to find out curl A at the point 1, 3, minus 2. Curl A is del cross A. So we have the determinant, and this will give you partial d by dy times minus x squared yz, then d by dz times x squared plus y squared times I. Similarly for the second term, similarly for the third term. So after differentiating, that will give you, this becomes minus x squared z. This will give you 0. And similarly for the next term is this one, and next term will be this one. What is asked? 1, 3, minus 2. So del cross A at 1, 3, minus 2. So at 1, 3, minus 2 will give you, substitute for x, substitute for y, substituting for z, that will give you 2i minus 8j minus 106k. Okay. Now the last problem, a equals xy cube minus y squared z squared I, then x squared plus z squared j minus x squared y z squared k. We are going to find out curl A at the point 1, 2, 3. So as usual, del cross A, you find out del cross A. So that will give you d by dy times minus x squared yz minus d by dz times x squared plus z squared times I. Similarly for the next term for j, similarly for the next term for k. So simplifying will give you, we will have to differentiate with respect to y. So minus x squared z. We will have to differentiate with respect to z. So z is nothing but 2z. This will become 0. So 0 plus 2z. So 0 plus 2z, that will be minus is there. So you go minus 5. Similarly for the ith term, jth term, and similarly for the kth term. So del cross A. What is asked? 1, 2, 3. So I wrote the same thing. So del cross A at the point 1, 2, 3 will give you. You have to substitute for x for 1, y for 2, and z for 3. So we have substituted here. Simplifying will give you minus 9i plus 12j plus 26k, which is nothing but del cross A at the point 1, 2, 3. So very remark one is A is a vector function and curl A is also a vector function.